Hello, this is Ray Safezadeh, Senior Director of Product Marketing at Expand Networks. Server-based architectures such as Citrix, VDI, terminal services are becoming more and more popular every day. These architectures are even more important when it comes to virtualization. So what should businesses look for in a WAN optimization vendor when it comes to server-based computing? Here to talk about this is Jonathan Crow, System Engineer at Expand Networks. Welcome, John.
Hi, Ray.
So, John, what is server-based computing? How do you characterize it?
Server-based computing, Ray, is characterized best by a remote client workstation accessing a server-based operating system to run applications or access data that's not stored locally on its own hardware.
Why do you need WAN optimization when it comes to Citrix ICA or VDI RDP protocols?
Well, Ray, essentially, Citrix, ICA, or Microsoft RDP, those protocols are very greedy. When accessing a server-based computing environment across the wide area network, typically those applications will consume the entire bandwidth speed, thus causing congestion, creating a poor user experience for the session itself, as well as limiting the bandwidth available for other applications crossing the WAN.
But aren't these protocols, Citrix ICA, VDIs, RDP, terminal services, aren't these all already optimized?
Well, yes and no. Both Citrix ICA and Microsoft RDP have native compression engines. At Expand Networks, we're able to provide the compression on our devices, freeing up valuable server resources and improving performance.
What is it about the Expand architecture that allows us to do a better job when it comes to server-based computing protocols?
Well, there are four key elements to our architecture. We have memory-based byte-level caching. We have very strong compression algorithms. We have a robust quality of service engine, as well as packet aggregation.
So let's start from the beginning. Why is memory-based byte-level caching important?
Memory-based caching is very important because it happens in the memory of the device as opposed to on the hard drive like the rest of our competition. And because we cache at the byte and bit level, we have greater visibility into the server-based computing packet stream.
You also mentioned compression. Can you elaborate?
Sure, Ray. Because we're looking at that packet stream at the bit and byte level, we can provide compression directly to that protocol stream, as opposed to our competition, who can only provide compression to the protocols around it.
What is the value of QoS, or quality of service?
Quality of service allows us to effectively remove congestion from the wide area network. This allows us to set maximum and minimum bandwidth restrictions on applications and provide a suitable user environment for server-based computing protocols.
What is the significance of packet aggregation?
Well, packet aggregation allows us to hold packets at either the inbound or outbound flow of the wide area network. This will allow us to effectively provide a resolution for things like latency.
The key seems to be that Expand gets them all working together, right?
That's correct.
John, I know printing is a big challenge when it comes to server-based computing. Can you elaborate on that?
Printing can be a huge burden on server-based computing in that it uses valuable WAN resources inefficiently. When configured properly, we can separate the print spool from the client session, provide our quality of service and compression to it, thus improving the overall user experience.
So, John, you talked about the features of Expand accelerators when it comes to server-based computing. Can you just summarize the benefits for us?
Expand provides several different areas of optimization for server-based computing, and we're able to bring all those together in one solution. With that, we're able to provide up to 1,000% performance increases over the native environment.
Thank you, Jonathan. That was an excellent overview of Expand Networks as well as its network optimization devices.
Thank you.